So today I'm going to talk about debugging Postgres Planner. I work at Pivotal and Greenplum, and until fairly recently I mainly worked on our in-house query optimizer. I think it's called Orca only internally, but so I'm relatively new to Planner, but I actually think sometimes it's helpful to hear about things from people that are newer to something. Someone who just recently learned the pain of fixing up your target list after changing your range table. So anyway, little preview joke for you guys. Okay, so I want to get started by talking about goals. So there's lots of good talks. If you just Google demystifying Postgres' planner, there's great talks. Robert Haas, Tom Lane, they've all done talks. This is something that you can find slides online about. So I'm going to go over some query optimization basics so that we can then go through a case study of adding sort of a trivial fix to Planner. Also, feel free to stop me, to correct me, or ask questions, because knowing the right answer is better than being wrong. Okay, and I've left time at the end for that as well. Okay, so query planning. Also, I should note that I've mapped a lot of the concepts from Orca directly onto Postgres, so some of the terminology I'll use may not be exactly Postgres-y. So here's a query. Select A from foo, and then you get results. What I'm going to talk about is the arrow in between. All right, so I personally break down planning into parsing, taking literally your query string and making it into a parse tree. And then I think of the rest of planning as two phases. So I think of it as like pre-processing, which is an Orca thing, and the rest of planning. And then obviously you execute the executable plan tree. This distinction is fairly arbitrary in Postgres because it's pretty fluid, but it serves my purposes, so I'm going to use it. So parsing, you can see the parse tree in Postgres. If you have to set the client messages to log at least to be able to see this, but you can set this guck, debug print parse, to see the parse tree. So I have this query, select A from foo, where 1 plus 2 equals 4, which we know is never going to be true. And you can see in Postgres there are these C language data structures that represent like nodes. So one of them is query, and here I've sort of like elided it to just the important parts and then color coded it. So you have the range table, which is, at least in this query, is basically foo. So it's like what we're going to be selecting from. Then you have the target list, and so not all nodes have target lists, but many nodes have target lists. In this case, when I say target list, I'm largely going to be referring to what is effectively the select list, just because it's easier for the purposes of this talk. And then you have so again, terminology-wise, the where clause, I'll call interchangeably qual, predicate, where clause. And in this case, we have an expression in our where clause, 1 plus 2 equals 4, and you can see that there's a node called an op expr, and it has two you can see the consts, I've highlighted them. Can you see that in the yellow? I don't know if you can see that. Anyway, so that is the query tree. And it basically, after parsing and lexing, it gets put into an abstract syntax tree that then gets sort of beefed up into the query tree. So it's not exactly an abstract syntax tree. But okay, so this is a visualization of it to make it even easier. It matches the color coding in the data structure. And again, color-coded. Okay, so pre-processing, what I'm going to call pre-processing. So I like to think of pre-processing as anything that can be done with exactly only what's in the query itself. So anything that doesn't require information about the data, the table DDL, anything that is based on basically relational algebra principles and is always better. So the transformation that you make is always going to make the query tree simpler in a way that is not worse. And also, I like to think of pre-processing as a separate step because it makes it simple to think about how do you make the tree more similar to trees from other queries so that the kinds of cases that you have to handle later in the code are fewer. I'm not sure if that makes sense, but basically like normalization on some level. So here, because 1 plus 2 will never equal 4, we can simplify this with constant folding to be false. Whoa. Okay. Sorry. Okay, so then this is a visualization of that process of doing what I've called pre-processing. So we take the whole op expression and we fold it into a const false. Any questions so far? Okay. So optimization is what I'm calling the rest of planning. Oh, question?
How do you validate that the folding is always strictly better?
That it's always strictly better?
Yes, in this case, it's pretty obvious that 1 plus 2 equals 4 being replaced with false. Heuristically, it's better.
Right.
With more complicated cases, how do you validate that it will result in a better plan strictly if I do something like this?
So with constant folding, there's sort of just like accepted ways to do constant folding from compilers and other things. Outside of constant folding, like, are you talking about other than constant fold? Okay. So for example, like pulling up subqueries is going to always, well, is usually going to be better into joins. Removing redundant group bys because like you just don't waste time is basically what it's doing, right? Like how do we not waste time and processing time? Other things that you can inline set returning functions. They're just like, I don't know. How would you answer that question? Like basically there are just certain things that you don't even need like heuristics. Like they're just always going to be better. I don't know. Anybody else want to chime in? I don't know if that was a sufficient answer.
I think it's kind of a normalization process as much as anything else, maybe.
Yeah. It should be not worse. It doesn't necessarily have to be better, but it's more about making it more uniform so that later stages of planning you can handle less cases. Like your input will be more similar to other inputs, I think.
Yes. Don't look at me. No.
I'm just, it can be an interactive discussion. I'm cool with that.
Okay.
Yeah, so the rest of planning, well, one of the important parts of planning is that you actually make an executable plan tree. So you want to make sure that you actually add access methods. And Postgres has this idea of paths. And so this is different than classically there are different types of query optimizers. And in this case, Postgres is a bottom-up planner. So as you take your query tree and you're making it into an executable plan tree, you'll add these different paths and decide based on cost. So it's a cost-based optimizer, which one is cheaper to the best of its knowledge at that point in planning. So if you have indexes, usually it's better to use an index scan, except. So all that stuff that's dependent on your data, your statistics, your system even, like the amount of memory you have, that kind of thing happens at that point. So one of the really cool kinds of things that happens during that phase of planning that people always like to talk about is join order. It's like one of the sexy parts of databases. So so basically join order is like the user puts in a query that's select A from food, join bar, join Baz, and it turns out that joining bar to Baz first will produce fewer tuples, so do that. Any questions? What's next? Okay.
I've got a question.
Yes.
And it's probably something you guys talked anyway, in which case I'll let you get on with it. You mentioned top-down versus bottom-up. And as you said, you've done both now. I wonder if you would care to speak about the differences you see. That's too hard a question. I think it's too broad in scope. I think it's I'll hear about it.
Maybe we could come back at the end since it's a little tangential.
You're right. You would never ask a tangent question.
Since we have the mic for the audience, it's not going to be possible for you to run around.
Oh.
So you can ask the question included in the answer.
Yes, let me do that. Sorry. Okay. No one watched the video because now none of the questions are going to be in it. Sorry. All right, what was next? Oh yeah, so now it becomes an executable plan tree. Obviously, these are very simple queries, and I've elided a lot of, well, actually I haven't in this one elided that much stuff. But anyway, so you can see how we have from our query tree, you remember we had a target list, and we had a range table, and then we had our confusingly named from expression, which is actually not just the from, it's also the where. I think that's stupid, but that's just me. And then there's the plan. So you can see that we have a plan tree. One of the things I meant to mention earlier. So in my diagrams, I've labeled, so the edges that you see are members of the structs. The nodes are like structs in the tree. So the plan tree itself is a member of the plan statement. So when you actually are going to execute a plan, you need other information than just like you need other information. So that is the other part of the plan statement. And you can see you still have your target list, which was like the results you're going to produce from the query. In this case, that target list is. And that var, so var is probably short for variable. I never really asked, but I think in this case, this is our A. And then you can see foo is the range table entry that's there. So you can kind of see a relationship between the plan and the query tree. I don't know. But the important part for my talk is that const. So the const down there that says const false, and the same one in the plan, you can see that during pre-processing, we've made it into a constant, and in the plan it still is. And it's in the member called res constant qual. So when that's not null, it acts as a one-time filter. So it will be evaluated, and then that's it. Like, you only need to do it once, which will make more sense in a minute. So now this is going back to talking about the data structure. So we have this plan statement. Similarly, you can see it if you have client min messages set to log at a minimum with debug prints plan. And I've color-coded it similarly. These slides are on my GitHub, which I'll show the link later, but the colors look better on a computer. So you have your res constant qual, and it has a const, which has that false, because it's 0. Any questions? Okay. Same color coding here. Yeah. Okay. So most of you have probably seen the most common representation of a plan that's exposed to a user. It's just explain. You put explain in front of your query, and you can see what the planner has in store. This, importantly, is like at the end. So the plan tree evolves throughout planning, and the explain plan is derived from the final sort of chosen plan tree. And so some of the terminology is a little confusing. So I said I would refer to the where clause usually as like qual or predicate or where clause, but in this case it's been turned into a filter on the scan. So that also kind of is the same color as the where clause because of that. Yes, and you can also see the expected rows and the number of bytes that the width that are expected to come out, which just noting that because later it's relevant. So now I'm going to go through a case study of adding a fix to planner. And we're going to revisit these topics and use them to build upon them. So why would you do this? Why would you hack on planner? Well, usually you should probably do something else first. And all of the other talks well, not all of them, but many of the other talks we'll talk about that. You could tune your database, like add indexes. You guys know the drill. Rewrite your query, probably less subqueries equals good, usually I hear. So, but if you still see a bad plan and you know that you've done everything else, then it's like kind of a fun idea, I think, to go in and try to see if you can actually do something to the code and change it. So for the purposes of the case study, 2 tables, 1 column each, both ints. Assume there's data. It's not very important, but there's some data. This is the query. Okay, so select A from foo, where null equals any, select B from bar. Okay, so what is this doing? It's going to go through every tuple in foo, and then it's going to decide whether or not to produce an A from that tuple based on the evaluating this condition, this expression. And if it's true, then it's going to produce that A. Now, this expression is basically, it's going to look at all the B's in bar and evaluate for that B in bar if null is equal to it. And it's going to do all of that for each tuple in foo. Okay, so I'm going to talk a little bit about null semantics just in case we don't all remember it from Wikipedia, which is where I got this. Okay, so two-value logic. In databases, null basically means unknown, so we get this part of our truth table. And the important part is that, so we have P and we have Q. And so if P is true and Q is null, what that's saying, it's not like it is null. It's saying, I don't know if it's true or false. I don't know. So P or Q, yeah, okay, P's true. So definitely like at least one of them's true. But P and Q, well, true and true or false, like if I don't know which one it is and they both have to be true, then the answer is unknown. And with equality, if you're saying true equals true or false, there's no, you don't know. So that unknown it's important. So three-value logic is important to the rest of this case study. And similarly with false. And if both are null, then you don't know anything. It's all null. So that affects our understanding of the query, right? So null equals any, select B from bar, will never be true. Anybody? Any questions? Okay. Cool. So now, what plan did I expect from this? I thought I would see a result node with a filter that was like, don't do anything. This is what I thought I would see. This is what I saw. So I asked myself, why? So let's look at this and just understand what it's doing. We said it's going to scan every tuple in foo. And then I don't particularly like the layout of this, but basically the one-time filter with the subplan, what it's saying is, for each tuple in foo, we're going to execute that subplan. And that subplan is going to scan every tuple in bar. It will put it in a cache, so it's not going to be too expensive, but it's still a lot of work to do nothing, to produce no results, right? And I happened to put 3 tuples in foo, so you can see the expected rows out is 3. So Postgres does a node, won't produce results. Any questions? Yes?
I think it actually doesn't evaluate for every row. It only evaluates a subquery for exactly one.
Yeah, so and then materializes it. But doesn't it have to go through in memory still?
Because it's implemented as a
one-time filter.
So it only does it once.
Okay, so you've seen every tuple from each table once, which is still more than 0.
Completely.
Thank you. Okay, so plan tree on the left, your left, is the one we have. The one on the right is the one I want. So the first thing that I do is ask myself if it's correct. Will I get correct results if I have the plan tree that I think I want? Because wrong results are usually not a good thing. So I don't have a proof for you other than the null semantics. It's never going to be true, so I think it's right. And so then you have to start thinking about actually how do you go from that tree to the tree you want. And you have to insert some new logic somewhere during the planning process. Okay, so to do this, we're going to go back to the query optimization basics that we talked about earlier and revisit parsing and preprocessing and planning. So when we parse this query, we get a query tree that looks a little bit like this. I maintain that the where clause is the important part, so I've allotted the target list and range table and all of that. So the qual there, you can see, this is again, the dotted line means it's not exactly one-to-one mapping with the exact structs and members. And the reason that I've used this terminology and the actual names of everything in Postgres is I wanted to couple it very tightly with its implementation in Postgres and not just talk about query optimization, because like you can go watch Stanford lectures on that. You don't need me to talk about that. I wanted to make it easy to go and actually like look in the code and associate what you're seeing with real code. If that makes sense. So the sublink that you see here is a kind of a special node in Postgres, and so it's going to anchor an expression that involves one or more subqueries. And then you can see we have on the left the subselect. So that query is our select B from bar, right? So then we have our op expression. So similar to our op expression in the initial query, where we had 1 + 2 = 4, this one is representing our null equals any. And that's why when you see in the bottom, I have a pointer. Okay. Yeah, that. Okay, the param, that param is basically short for parameter. So it's going to substitute in the result of evaluating the subquery to compare it to the constant on the other side of the op expression, which is null, before determining whether or not it's going to produce results. And that's why all of that is in what's called the test expression of the sublink. So it's the test that you have to pass, I guess. One way of putting it. Any questions? Okay. So now what I called pre-processing before here. So it's not like we don't do anything smart right now. We do pre-process and constant fold the op expression into a constant null. Well, it's not true, I guess. But the sublink node remains. So we go from that yellow box to the other one, which is kind of like where select null from bar, roughly, I guess, by doing the constant folding. But because the sublink is still there, it gets turned into a subplan. So you can see here, this is the executable plan tree we get from this. And so my guess was, it's hard to know everything about Planner. So usually when I'm trying to figure out what to do, I just try something and say, I think maybe the sublink's getting turned into subplan, and if I get rid of it, then I will be able to get rid of the scans I don't want. Not because I know everything about Planner, but because that seemed like a good thing to try. So that's what I decided we would try. So sublink gets turned into a subplan. And so now asking, like, what part during planning should we actually add the change? Where's the right place? There's a lot of ways to get correct results, probably. So it's very subjective where you should put it. But in this case, if you go back to the actual query, so everything that we have, everything that we need to know in order to make the kind of change that I'm proposing to make is available in the query itself. So I maintain that pretty soon after parsing and making it into a query tree that you could add the change fairly early on. But that doesn't really answer what the new query tree should look like. So the next step for me was coming up with what I expected the query tree to look like. And usually I do this by looking at analogous queries that do have optimization, some optimization that's desirable that occurs. So like, just switch out the sublink, or use a different kind of sublink. Change pieces of the query until you get a plan that's more close to what you want, and then look at where they diverge. And the other thing that I do is sort of look at the optimizations that are already being applied. So we are doing constant folding, but we just aren't getting rid of the sublink. So this is what I thought the query tree should look like. And the qual should just have a constant null, and then we wouldn't produce results. And that would end up giving us a plan, I thought, with a result node on top of a constant, a constant null. So now let's talk about some of the functions. If you wanted to add this fix. So subquery planner is one of the sort of like top level planners in standard planner, I guess. So it's it will recursively process all the subselects in your query, including the top one. But it also kind of before calling some of the other planners like grouping planner, it will do some of the pre-processing that yes.
So trying to understand, so you wanted to execute the subquery and then find the result and then go back to planning?
So the question is, I wanted to, sorry, repeating the question is hard when, okay.
So are you trying to actually execute the subquery and then find out what those values are and then compare them to the other side? Or are you just using the fact that null equals something is going to end up being null?
I'm using that. So I'm using that. I don't need to execute the subquery to know that it will never be true. So I can rely on null semantics and the fact that it's in the where clause to make that optimization early.
Okay. Do you think it's worth considering, like if you had where 5 equals any, do you think it's worth considering whether we should try to like execute and then go back to planning?
So I don't actually, I would assume there are some cases with any sublink where that optimization is done with constants, but I'm not sure actually. But it's harder, right, because that could be true. So you would have to go more into the machinery of like actually doing some evaluation and then seeing if it's equivalent. So yeah, this fix is very, very narrow, just to like the case where your constant is null. But yeah, that's a good question. So subquery planner is going to call preprocess expression. So as I mentioned, there are several different things that many things that subquery planner does, but the preprocessing expression will go through and do exactly what it says it's going to do. It's going to preprocess your expressions, and it will call the constant folding walker eval const expressions. So this is sort of the place we're going to focus a little bit more today, which is like it's going to basically take things like 2 + 2 and reduce it to 4, right? So, and yes, okay. So right now we are using the constant folding walker to go ahead and take that op expression and make it into this const. So can we? My thought was that we could add a case. I'll go to the next slide. Okay, so we call subquery planner on the top level query, and then on the qual we call preprocess expression, and that is going to end up being called on the rest of the tree. Everything kind of gets called everywhere on the tree, and then if you meet a set of conditions and constraints, then at that point a mutation can be applied. So in this case, we do actually try to do constant folding on, like we call eval const expressions on the sublink, just because we call it pretty much on everything. And just like in other places in Postgres, there's a big switch case, and there's cases for most of different node types, but there's not one for sublink, which I feel is probably by design because sublink's special. But I thought, what's the harm in adding a case for sublink? So basically, in that constant folding walker at the bottom, pretty much, I just added a case for sublink and said, hey, if it's this type of sublink, because it only really works with any, right, which I'll talk about in a minute, and I do constant folding on its test expression, which is this yellow box, and I get the result, and the result is a constant, and that constant is null, then instead of returning myself with some mutated subtree, I will return that mutated test expression, so just that const. And so, yes, adding a sublink case to the constant folding walker. Will we get the tree we want? And it seems like a good idea, but it's not good, not a good idea. And I'll talk about that. So now we have to go back to null semantics, unfortunately, and talk about any semantics. So when we are evaluating this expression, we're asking, does any b in bar equal an unknown, right? Does anyone know this, where I'm going with this? Okay. So now, because Postgres is fancy, they let you put this in the select list. And so we can actually ask Postgres the answer to this question. So here, the answer is null. That seems like what we expected, right? Based on null semantics. But what if there's no data in bar? So yeah, then it's false. If you think about it, it makes sense, kind of, maybe. Which is that, is there any B, and is there a B in bar that's equal to unknown? And if there are no B's, then I guess we know the answer is no. At least that's what I told myself. So yes, these are different answers. Okay, so now for our original query, which had this expression in the where clause, it produces the same results regardless of the data in bar, because it's in the where clause. It's being used to filter whether or not we produce results. It is not the answer. It is the result of evaluating the expression is used to filter whether we produce an answer. Is that clear? We can go back. Anybody? Okay. So if we go back and look at the query trees of our two queries, so when the expression is in the select list, you can see that it's the target. In the target list, it's basically what's going to be produced. And when it's in the qual, it's what determines if we're going to produce it. So where it's in the where clause is on the right. Oh. Okay. Yeah. So you can see why that would be wrong, because here we've turned it into a null, a constant null. So that means regardless of the data in bar, it will always produce null. It will never produce false, which will be wrong sometimes. So does that mean that we can't do this optimization? I mean, that's very possible. Obviously, I haven't but I had another idea, or sort of another idea. So we already called preprocess qual conditions. Like, we wouldn't have gotten where we are if we didn't. So this function basically is so we talked about the call stack with subquery planner and preprocess expressions, and so we only call that once we have called preprocess qual conditions. So we sort of specifically call it on different parts of the query. We call preprocess expression. So I thought, why don't we actually just move this up to preprocess qual conditions and do basically the same thing, but a little bit without adding a case for sublink to the constant folding walker, which felt really brittle to me. So I just, in preprocess qual conditions, same logic. If it's a sublink node and it's a sublink any, because this won't work for all. For example, if you have equals all, that's true when the table's empty. So then if you do constant folding on that sublink's test expression and it comes back constant, and that constant is null, then replace the sublink with that constant null. So basically the same logic as before, but just moving where I put the logic. Everybody okay on that? Okay. So we get the query tree that we wanted, and in the case where you have it in the select list, it doesn't do it there. And so we have the desired query tree, we get the desired plan tree, and this is the plan. So it did work, and it passes ICG, but again, that's doesn't necessarily mean that it's right. Which leads me to the end. I invite you to go and look at the code and tell me why it's wrong on my fork of Postgres. And my slides and a README with some of the terms that I used today are there. So project and target list and tuple and relation and things like that. And also read the Postgres README in the optimizer directory of the source code. It's really good, very detailed. Someone must have spent a really long time on that. So take a look at that. Yeah. That's it. Does anyone want to ask any questions? And I think we finished early. I don't know if we did. Yeah. Yes?
So besides from expression, what's the dumbest structure name you found?
I don't know. I think that was the one that made me the most sad, because it's very confusing. Otherwise, some things are inscrutable. I don't know what range table is. Is that a database thing?
It's an artillery thing.
Makes a lot of sense.
If you think about it, so that's where the term comes from. If you were firing artillery, you have to what do I want to hit? Okay, you look it up in the table. Googled it once, that's how it works. So that's silly as well.
Question over here?
How do you know that
Well, technically I got it to work by adding a lot of if statements. So like, if this and this and this and this are all true. So it still passed all the tests that were there, but I kind of feel like there's a reason that there's not a case for the sublink node in the constant folding walker. And that I generally think when you add code, you don't want to give the wrong signal to future developers, and I felt like that signal at the very least would be an uneducated signal. So it should only be done, whatever it was that I was going to do should only be done in the qual was what I was trying to say with my code, so I just felt like it was better said somewhere else. I'm not sure if that makes sense, but...
So if I understand you correctly, Postgres doesn't prove plan equivalence while doing constant folding. It's the unit tests that tell you that you're wrong.
Well, unit tests are a strong term, but proving plan equivalence is actually like a problem that's not possible. Proving constant equivalence, yes, but so Postgres doesn't prove plan equivalence, and there aren't tests that will help you tell if your plan is equivalent. You have to use, I guess, like I mean, you sort of have to just like ask yourself a lot of questions. I don't know, actually, that's a really good point. Yeah.
I kind of think that would be something that you would do better at if you had the alternative design, right?
Which,
alluding to my earlier question about bottom up versus top.
Oh, yeah.
That would tend to imply that it would be easier for that kind of thing.
Yes, so I find that architecture of planner easier to reason about.
I think everyone.
Yes, so I had the benefit of that. So working on another optimizer, what I found was that if you have a discrete transformation step that is explicit in terms of the constraints that it has, what it applies to, when it is okay and not okay, it's easier to assert sort of like, to be clear about your assumptions and what's true and not true. With Postgres, it's much less clear what is true and what's not true and what applies at a given moment, because there's not a centralization of like a single mutation. So if you're gonna redo join order or something like that according to one algorithm, it's not like in one place, it's like everywhere, kind of, like in the sense that, okay, that's a bad example, but basically if you have some sort of modification and you say these two plans are semantically equivalent, I can add this transformation, and regardless, maybe it'll be a worse plan after, but I know that it will be semantically equivalent, then it's easier to reason about and to add a new step or to sort of like modify that step and make it more efficient. But if that mutation happens to different parts of the query spread over the whole planner, then it's much harder, because you have to say, okay, well here I'm doing it in grouping planner to this, like to these things, and over here I'm doing it, so.
But there's a recursive substructure in the browser, right? Like you install it once, then it carries forward.
Right. Yes. Yeah.
I just find it like mildly concerning that this seems like a form stack problem to me. I understand like the art and all that, but like it's kind of concerning that there's no way for me to be sure when I'm actually writing and executing, as opposed to just depending on some test to tell me that, hey, you might have screwed.
So.
That just seems so.
Yeah, like, and you mean a test like a proof, kind of.
Exactly.
Yeah.
Proof is from a unit test, as opposed to just having something tell you, yeah, that's not okay, because through reduction it doesn't equal. So.
Yeah, those would be really awesome. Actually, recently Tomlin added some unit tests having to do with some of the things we're doing with predicates. I don't remember. Does anyone? Some of the logic around that, and it actually uses. Yeah, it's super cool. Check it out if you haven't looked at it. He uses SPI to get he starts with the query, so it's not like a unit test, but he calls one function on it that does mutation of something with the predicate, I don't remember what, and then asserts on it after to serve as to make sure the proofs are still working. If you find me later, I can give you something that's more useful than that, but those are the only such tests I've seen specifically in Postgres.
I have another question.
Yes.
So I can think of a couple of things, and I'm sure you can too, where, so obviously that example was for purposes of illustration, so
Yeah.
somewhat of a toy example.
Yeah.
But there are other things that come to mind that we don't do that we really ought to do. You said something, I believe, about it being subjective and you having to weigh. This is kind of a black art, right? But there's clearly like 2 or 3 things we don't do that we ought to do. Do you have any particular feelings on that? Like, is there 2 or 3 sort of bumper items that come to mind that we don't do optimizer-wise we ought to?
So, based on the limited experience that I have in databases, mostly what I have are analogs in the other optimizer we have at Pivotal. And so some of the things that Orca does really well around subquery pull-up in more cases and things like that. But if I enumerated them, I would be pretending that I had come up with them on my own. So the answer is no. Yes.
I think you can do that at this point.
Okay.
I was still like a half understanding. So look like we don't know the research curve. So it's like is this like an academic discussion or does it have any practical?
So it's mostly a toy example. It actually came out of a real, we had some bug in Greenplum around simplifying test expression. And so there was a PR for it, and in the end, the test expression was just a constant. And I was like, and it was I don't know, some customer had a BI tool that made something that had a nested subquery like this. And so it was null equals subquery. And I was like, well, do we even need the subplan still? But I don't know, maybe someone else can answer it better.
I was going to say, we do sometimes see discussions on the mailing list about apparently stupid optimizations that come from ORMs, because ORMs often generate stupid queries.
Yeah, and I was sort of half thinking of pointing out, when you're talking about constant folding and stuff like that, a lot of it seems obvious, but then when you consider, say, inlining SQL functions, some apparently dumb thing is actually perfectly reasonable.
Right. Inlining is a good example of when you might see this in the wild.
And so how do you avoid such things? We cannot change the right?
You can come to the community and tell the community, hey, I have this problem and I have an idea, and in all likelihood you might have missed something and it's not possible, but in a lot of other chances, like, oh yeah, it's actually like a 3-line change. Yes, but or you can sometimes see like, hey, I looked at the source code and I only need that tiny change in my query, and suddenly the optimization is possible. Like, but it's obviously not the first step.
Yeah. I mean, this was like 3 lines of code or something like that, like to change this.
Yeah.
So.
The difficulty with the R optimizer, I think, at least, is that there's about 1,000 places you could do any one thing.
Yes.
It's not exactly. Who knows which one you should choose?
You just asked Tom Lane.
You just have Tom Lane.
But it will differ, and the answer will differ between Monday and Friday.
Well, you just propose the wrong one, and then on Friday the right one will be admitted.
Yes.
One thing that I found particularly frustrating was that there are assumptions because that the code makes. And so the example was that David Rowley's doing the same thing that we do for group by with distinct, removing columns. And I reviewed the PR and I spent a really long time trying to think of really cool edge cases. And then in the end, I was like, nope, this seems correct. This seems right. Yes, I don't think this could ever break. And then with a very trivial modification of one of the test cases that I tried, Tom Lane managed to crash the database. And it wasn't based on correctness of the actual mutation. It was based on some assumptions that the code has, and those to a developer it's not even close to obvious. It's not even not obvious. It's just there's I don't even know where to start. That was probably my most frustrating experience with Planner, was how is it that something like that can't be codified anywhere in an assertion or I don't know, in a test or something like that. But I think that the Planner is definitely room for people with fresh perspectives to come in and find ways to make it easier to contribute. And that's one of my goals at some point, is to make it easier. I think that tests are especially important for developers, but I don't think I've worked on it long enough to really have any super awesome ideas.
I think one small thing might be, it's a silly thing, but the representation you showed if that was in JSON, I think actually that would be really handy.
These are all in ticks, which isn't that helpful, but they're generated with ticks. I guess I could put them in JSON, yeah.
No, I'm not saying not you in particular, but if they happen to be generated in that format in the first place, then you could manipulate them.
Yeah.
If I don't know if that's JSON or something, I think that actually would be useful in some cases.
Right.
You mean you don't want to have C a file in over 300 pages?
Often, no.
5,000 lines later.
Like the fact that it's not, it's just in this obscure, it's Lisp, common Lisp thing. What's it called?
Well, it's mutant S expressions.
Yes, mutant S expressions is that's a silly. That would
Yeah.
be great if we decided to have something manipulate easily.
Yeah, actually, it's super unapproachable, and anybody that has ways to make it more approachable and wants like help on their project doing that, let me know, because I would love to help.
All right, I'm signed up to review Tom's. Do you know that patch that Tom wrote that's been dragging? So you want to tell a story?
I mean, there's a problem that at the moment, if you have a query with 2 ORs, it can be very unoptimized, and it would be faster if you convert it into a union.
Mm-hmm.
But we haven't managed to convince ourselves that the transformation is correct in all cases. To go to your point. And since it has now lingered for like 2 years,
Yeah.
because nobody really
Theoretically,
has the
I'm
guts to
Theoretically,
say, you're right.
I have the well, actually, no, I just signed up. But so what I suspect to be true, and it's a very, very sort of, I don't know, kind of, it's very driven by intuition and not. It's hard to have any certainty. But I feel like there's some broader way of framing that particular optimization, but I don't know. So I'm way out of my depth, basically.
Does anyone know anything about? I think it's called Cosette. It's like a theorem prover for.
I read the paper on that, yeah.
I think I just read the title.
Yeah. I got like only halfway through, yeah. I really wanted to actually think about using it not to like for the optimizer itself, but to make some test framework around expectations to help new developers. So like, yeah, but I haven't gotten all the way through yet.
Last time I looked, the restrictions were making, I could assume you had no union, just union all, or the other way around. Like the restrictions were so bad that it wasn't quite real life yet. But I don't know when that.
Thomas's question was about research on automated proving of provers for SQL. Yeah, so if any of you have like, please work on that and then tell me about it. That would be great. Thanks.
I actually brought this up at dinner with a professor from Russia, and he shut me down in like about 15 seconds, and he was like, NPR not possible.
Yeah.
I mean, just because it's not generally possible doesn't mean there is no transformation that are provable.
I mean, join orders NPR'd, right? So.
Yes, but that's why we like collapse eventually after 12 to like get.
Well, no, but there's all sorts of like different heuristics we use to shave off like actually doing it.
That's the thing.
Yeah, but couldn't you do the same thing with?
I think that we can do better than nothing.
Be like proof in finger quotes, right? I think we're probably over time. I don't know. No, we're not. My presentation was very short.
Yes.
Some. Oh no. Okay. Yes.
So, just to go back to the example that you were looking at, and correct me if I misunderstood this, but the expression in the subquery with null equals any would mean that is false if that table is empty, null if there's anything in it.
Mm-hmm.
Is there a step or an opportunity in the pipeline where you could make that optimization
to check if it's
scanning B, like just say like, hey, if there's anything in B, like then it's this, and if there's not, then it's that, but you don't actually have to go through every row in B to evaluate that?
I thought about that, yeah. So the question was, can you actually check if the table's empty earlier on and use that to be able to make the planning decision correctly? So I actually, planner, I don't know where the line is, but you would need to actually like go and find out that the table was empty using statistics or whatever. So usually there's like a line where it's not appropriate to start thinking about that, but I actually don't know where that line is. I don't think it's that early in planning, but
you could just attack a limit one at the query, and that would make the check quite cheap, and you would then get the correct answer at runtime, and it would make kind of get both kind of right, and you could do it in the calculus as well.
Mm-hmm.
The gross though.
Yeah, so one of the things about that is like if you look at the code in general and you don't see things like that, it's like maybe someday I'll be that gutsy. I'll be like, screw it, I'm just gonna put a limit 1 in there. But like if it's correct, then it's totally valid to, show people and bring it up, and like especially for an optimization that might be more impactful, like put your idea out there, and then if other people have more like ways to do it in a more Postgres idiomatic way, then like they'll tell you. So never be like, my idea is stupid, I'm not going to tell anyone about it. Okay, I think that's it. Thank you.